In this problem, we're given 4 tables of data. We're asked for each set whether the data represents a function. If it does represent a function, we're supposed to tell whether it's increasing, decreasing, or constant. For the first set of data, since the definition of a function is that every input, x, has to have exactly one output, y, meaning it can't have more than one, I'm thinking that this one represents a function. For example, if you plugged in 3 into this function, the only output you'd come out with is 18. There's no other place in the table that says that 3 gets sent anywhere else. And you'll see this is true for 4, 5, 6, 7, and 8, that every input has only one output. Since it's a function, I now have to tell whether it's increasing, decreasing, or constant. This one's increasing. The definition of an increasing function is such that if x increases, y increases. And you can see this in the table. As x gets bigger, as I go down the list, y also gets bigger. So I'm going to say that this is an increasing function. For the next set of data, I start with 317. Looks like it's a function so far. The input 3 has exactly one output, namely 17. There's no other place in the chart that says 3 will have a different output other than 17. When you get to 4, however, seems like there's 2 outputs. This says if I plug in 4, I'll get out 19. Later on, it says if I plug in 4, I'll get out 25. If someone were to ask me what the output of the function is at 4, I'd have to say there's 2 outputs, 19 and 25. So even though this could still be considered a relation, it does not fit the definition of a function. So I'm simply going to say it's not a function because I have an input that has more than one output. It has the output 19 and 4 has the output 25. Moving down to the third table here, if you plug in 3, you only get one output, 182. There's no other place in the chart that sends 3 to some other output. The same goes for 4, 5, 6, 7, and 8. So this is a function. Now I have to ask myself, is it increasing, decreasing, or constant? So what happens as x increases? As x increases, 3, 4, 5, 6, 7, 8, what happens to the y values? Looks like they get smaller, 182, 168. The numbers are getting smaller all the way down the list. So for every single example, as x gets bigger, y gets smaller. This is the definition of a decreasing function. My last table might be the most confusing one of all. For example, if you plug in 3, you get out -7. So far it fits the definition of a function. For this input, there's only one output. But notice I really don't care what the output is, I only care how many there are. So this input has one output. The fact that it's -7 is actually irrelevant. The fact that there's 1 is what is relevant. When you go down to 4, this indicates there's an input that has exactly one output. If you plug in 4, you only get one output, namely -7. Some people are bothered by the fact that it's the same output we got before. But the definition of function does not necessitate that the outputs be unique. You can keep getting the same output over and over again, and that's okay. We don't care what the output is. We care about how many there are. If you plug in 4, you simply get one output, and no more than one output. You get -7, which is one output. This is true for the rest of the x values. Each x value has exactly one output. The fact that they're always the same is irrelevant. We care about the number of outputs, not what the outputs are. So this is a function. So now I have to say whether it's increasing, decreasing, or constant. Well, this is a constant function. The definition of a constant function is that no matter what you plug in, the y values are always the same, hence the word constant. If you were to graph this, this would be a horizontal line. I'm going to go down here and select that it is a constant function. And that's basically the end of the problem.